Okay, here's the video notes for Science 8, topics 4 to topic 6. So topic 4 is flow rate and viscosity. And so flow rate and viscosity, the property that describes a liquid's thickness or thinness is called viscosity. Things that have high viscosity like molasses, corn syrup, and there are some things that have low viscosity like air and ethanol. A thicker fluid is more viscous and has a higher viscosity, and some liquids will flow faster than others. The time it takes for fluid to flow from one point to another is called flow rate, and the units are how many mils flow per second. We did lab activity, and here are some calculations for flow rate. So the formula is volume divided by time. So for example, if 200 mil flows in 10 seconds, calculate the flow rate. So you just go flow rate is volume divided by time. Flow rate is equal to 200 mils divided by 10 seconds. So then the flow rate is 20 mils per second. And here are some other calculations for it as well. And we did a lab where we did flow rate, how much would flow per second. We made a quick, that's a horrible bar graph, but I made a quick sketch of it, and we can see here the flow rate is highest for ethanol and the flow rate is lowest for syrup at 21 degrees Celsius. And then we read through pages 45 and 46 together, and some examples of different industries where viscosity is important to their products, like paints, makeup, anything to do with mechanics, making of candy, and we read page 48 together. How does the viscosity of liquids vary? Even though all fluids flow smoothly, they flow at different rates because liquids have different viscosity. And once again, a high viscosity means a high internal attraction, and that means high internal friction, and it doesn't flow as well. For low viscosity, it would be the opposite. And particles can move around, but may be difficult for them to pass each other at high viscosity. Viscosity of a fluid or a liquid decreases as it's heated and increases as it's cooled. So oil flows better when it's warm and flows poorly when it's cold. Another way to define viscosity is resistance to flow, which, like I said earlier, resistance to flow creates internal friction, and resistance occurs when two substances are rubbed together. For example, it's easier to skate on ice than on pavement because there's less friction on the ice. And water particles slip by each other easier than oil particles because the attractive force of water molecules to each other is less than those of the oil. And warmer fluids flow faster than cooler fluids because heat decreases those attractive forces. And as well, warmer fluids, the particles are moving faster as well. How does the viscosity of a gas vary? Gases flow differently from liquids. Particles are further apart and the attractive forces are low. So if you heat a gas, you kind of get the opposite effect. It causes the particles to move fast, so they collide more often, and that means there's more internal friction. So the viscosity of a gas increases while it's heated, and it decreases when it's cooled. So that's the opposite of a liquid. So a little counterintuitive, so make sure you pay a little bit of attention to that. And then we looked at density, and there's the triangle that we looked at. And so if you want to figure out density, you cover up D and you get M divided by B. If you want to figure out mass, you cover up mass, you get D times V. And if you want to figure out volume, you cover up V and you get mass divided by density. Some things you should know: the units for density is gram per mil or grams per centimeter cubed. Mass is in grams, volume is in mils, or if it's a solid, centimeter cubed. And of course, we all know the density of water is 1 gram per mil, kind of the standard that you're expected to know. The density is mass per volume of a substance. In general, solids are more dense than liquids, and gases are less dense than liquids. And the exception to that is water, right? Ice is less dense than liquid water. Although liquid particles are sometimes quite closely packed together, they cannot support objects in the same way solids can. When you move through air, you don't have to move as many particles of air out of the way as if you are walking in water. So that's why it's easier to walk through air than it is to walk in the swimming pool. Solid, liquids, and gases, quick review. According to the particle theory, the solid particles are packed close together, simply vibrate, they're moving really slow. The liquids move a little bit faster, and so they can slide past each other. And then the gases move the fastest. They're the least dense, and there's a lot of space between the particles. The force of attraction is the same between all of them, just you need to realize it's the speed that affects whether a substance is a solid, liquid, or gas. And then we went through the table on page 52. We looked at densities and we filled that in. Density of solids, liquids, and gases. When substances are heated, their particles take up more space, which means that the density of substance decreases. And usually the density of a solid is greater than the density of a liquid state, which is greater than that of a gas. Water is the exception to this because water gets less dense when it freezes. That's why ice cubes float. Liquid mercury is so dense that you can actually support an iron bolt on top of it. And another example of a liquid supporting a solid is wood floats easily on water. We went through and read page 53 and filled out the definitions for that. Density is a way of expressing mass to volume ratio, how much matter something contains in a certain limited amount of space. To find density, you get the mass from a scale, volume by either doing a calculation, length times width times height, or if you want, you can measure a liquid in milliliters using a graduated cylinder, or you could also use Archimedes' principle and see how much an object displaces. Okay, and then you divide the mass by the volume. So we talked about this formula. We did some calculations with it. There's your triangle again for the density. And density of solid is expressed in grams per centimeter cubed or grams per mil. The density of fluids, liquids, and gases are often given as grams per mil or grams per liter. Notice that 1 mil is 1 centimeter cubed. That's for water, anyways. As long as the temperature and pressure stay the same, the density of a pure substance will remain constant, which means it doesn't change. And then we did some calculations with density. So here we can see 70 grams takes up 100 centimeter cubed. There is our triangle. So cover up density, we have mass divided by volume. And so 70 grams divided by 100 centimeter cubed. Density is 0.7 grams per centimeter cubed. And so if you figure out the density of three substances, like this is oak and water and iron, you can see the less dense fluid is at less dense materials at the top, greatest density is at the bottom. And we did some more practice. And then topic 6 deals with buoyancy. So buoyancy pushes up and gravity pulls down. So if buoyancy is greater than gravity, it floats or it rises. If gravity is greater than buoyancy, then it's sinking or it's already sunk and it's at the bottom. And if gravity and density are equal, we have neutral buoyancy. So it literally floats at a certain level. I don't know if floats is the right word. It just stays at a certain level. And buoyancy pushes up, so we call it the anti-gravity force. Okay, and I already talked about this on the last page. That's why it's easier to lift someone up in a swimming pool because the water is helping push that person up. But if you then try to carry them out of the pool, that buoyant force is no longer there, and then you have to lift the entire weight of that person. Factors that affect buoyancy: the density of a fluid. So salt water is more dense, so it has a stronger push up. Like the Dead Sea, you can actually float in the Dead Sea. You don't have to do anything. You just literally sit in it and you stay at the top. The surface area can affect this as well. So water can support objects with greater densities, with densities greater than water, as long as the weight of the object is spread over large enough. That's why a steel ship can float, right? It's spread over a large surface area, and of course the average density, because now the ship is full of air, will work. That's why when a ship gets a rupture and fills up with water, the average density is higher than water, and the boat sinks. And of course the design of an object would affect this as well. Average density is the total mass of a substance divided by total volume, so it's still mass divided by volume. So for example, when you wear a life jacket, if you fall in the water, it lowers your average density. It allows you to float. So it doesn't have to support your entire weight, just the weight that is not water. Fluids like air, salt water, petroleum are solutions. They contain more than one pure substance. So the density of the solution is actually an average density of it. And then we looked at the submarine example, right? So same idea. If the submarine is floating at the top, it pumps this chamber full of air. Okay, so that means buoyancy is greater than gravity, so it goes to the top. If it's sinking, it actually pumps the air out and pumps water in. And so the density of the ship increases, and as long as it's bigger than 1, that ship will then, submarine will start to go down. And if you want to rise, you want to blast that water out, fill it with air, and then once again the average density becomes less than 1, and it goes to the top. But if you want to be right here, it's kind of in the middle, you'd want the force of gravity pulling down and the force of buoyancy pushing up to be balanced. And of course, here we have this object, 5 kilograms, 5 Newton force, but as soon as you put it in water, it only is pulling down, you're only recording a 3 Newton. That's because the water is pushing up with 2 Newtons. Archimedes' principle. Archimedes discovered how to measure the volume of an irregular shaped object in public baths. Basically, he sat in a bathtub and it overflowed, and he went, Eureka! And figured out he could figure out the amount of liquid displaced. And he argued that the water displaced must have the same volume as the volume of the object. A scientific principle stating that the buoyant force acting on a submerged object equals the weight, force gravity of fluid displaced by the object is Archimedes' principle. And how are buoyancy and density related? The higher the density, the greater the buoyant force is basically what it is. The lower the density, the lower the buoyant force. So here's a person in the Dead Sea, literally just sitting there reading a paper. He doesn't have to do anything because the density of the Dead Sea is 1.24. Freshwater density is 1. And your human body is slightly more dense than water, not a whole lot more. That's why if you take in a big breath of air, you could float in the pool. And if you let all the air out, you tend to sink. And I showed you hydrometers, how they work. Basically, you have a tube that's balanced, you have a weight at the bottom, and you have markings of density on the side of it. And there's different sized tubes for different sort of densities you want to figure out. If the density of the fluid is higher, this will float higher, and then you can get a reading for it. If the density of the fluid is lower, it's just not going to push as much, it will sink more in. And we did a quick lab with this. And then we finish this up, and that is the end of outcome 3, which is topics 4 to 6 notes. Oh, and good job, people who did the study skills that I showed. The overall over 2 classes, we had a jump of 15% compared to the last quiz. So that was awesome, and further proof that studying actually helps.